Hi everyone, more of these equations. We've got x on both sides, well I'm going to call number 5, and I put the big issue of and fractions. One of the rules I keep saying to people is get rid of fractions first. So many people struggle with fractions, so let's just get rid of the fractions first. By the way, this is a divide by 2, and how can I get rid of a divide by 2? The opposites to both sides. The opposite of divide by 2 is times by 2. So, I'm going to talk about it first. I could times this by 2, and that one by 2, and that one by 2, and that one by 2. By the way, there's 4 terms there. Everything gets separated by a plus or a minus is a term, and also there's 2 terms on this side of the equals, and 2 on that side. So there's actually 4 terms. So when I multiply, everything gets multiplied. I said years ago, I had one student would get this like this, write a bracket around the whole lot, and multiply everything by 2 like that. Some people like it. Just have it as a mention. If you'd like to do that way, that's okay. If not, let's go back to this. If I multiply this one by 2, I multiply that by 2. Now this is the long way to do it, but I'm going to do it on purpose. If I multiply that one by 2, by the way, I make that look like a numerator, and that by a denominator, the top and the bottom. If I multiply that one by 2, I multiply this one by 2, and everything has to be multiplied 2. I just can't ignore that 3, I can't just ignore the 1, I've got to multiply everything. Let's see what we've got. 2 over 2 is 1, so I can cross them off, they become 1. Not that they become nothing, they actually become 1. So let's have a look at what we've got. They cross out, and I'm left with just the x. Could say 1x, 3 2s are 6. This one is 2x on 3, which is a bit annoying. So numerator is 2x, and these are 3 on the bottom, and the 2 1s are 2. And you go, oh my goodness, I've still got fractions. I've got to get rid of that fraction still. So this time, instead of multiplying by 2, I'm going to multiply by 3. It's a divide by 3, the opposite is times by 3. I multiply this one by 3. Just remember, I'm going to multiply all of them by 3. Can't just ignore the 2. It's also there. Multiply it by 3. And what have I got now? I've got a 3x and I've got an 18. The 3's cancel and I've still got that 2x left there. So there's your 2x and there's the 6. Let's have a look at what we've got now. I don't want the x's on both sides. I want it to say to me the answer is. I want the equation to tell me the answer. This is called making x a subject. When I was a child, you used to have to put x on the left. Really mathematically you should, but a lot of people don't worry if you put it on the other side. So, I don't want x's on both sides. If I wanted to go take 18, I could. If I wanted to do everything and shortcut, lots of things we can do, but at the moment, I'm sticking to one method. I don't want x's on both sides, I only want it on the left hand side, so I'm going to get rid of that 2x. So if I take 2x from that side, I take 2x from this side. So 3x take 2x is 1x, I can just write x plus 18, 2x take 2x is gone, and I'm left with a 6. Now, a bit hard to guess that, some people will look at it and just know what the answer is. Want to get rid of a plus 18, opposites to both sides. If I minus 18 from this side, I minus 18 from that side. What am I left with? I took away more than what I had, so that's minus 12. And so the question tells you the answer. I could put it back in there and do that. So what we did first was multiply by 2. Then we multiplied by 3. So on this question, get rid of 2 fractions. I can multiply by 2 and then multiply by 5, but this time I'm going to do it all in one go. So if I multiply by 10, the 10 will cancel out the 2 as well as it will cancel out the 5. So this is nice because it saves a bit of extra working out. So 2 and 5 will both fit into 10. So actually we can talk about the lowest common multiple of 2 and 5. Some people will just think of 2 5s are 10, and that works. Sometimes it's a bit trickier, but for the moment it'll do the job. If I multiply that one by 10, I can't ignore the minus 10s. Don't neglect it. I multiply this one by 10, and I multiply it, can't neglect the 1, it gets multiplied. So what we multiply one side by 10, everything on this side gets multiplied by 10 as well as everything on that side. There's people who teach it with brackets and all sorts of ideas. How many times does 2 go into 10? Well, 10 divided by 2 is 5, so I just write that as a 5x. So 2 into 10 goes 5. I could put x5, but everyone writes the numbers first. 3 10s are 30. It's got a subtraction. How many times does 5 go into 10? Twice. So that's 2 x's, and we've got a 10. So it's nice to do it all in one go. It certainly is better in the long run. Now, creature of habit, talk about our habits. Could get rid of 2x if you're confident. You could do the other way. You can do whatever you want. There's lots of things. But please, watch out for all the traps. You might notice, well, I'm going to get sidetracked here for a second. I'm not going equals. All these equals are extra. You'll never see a math teacher write it down there for an equation. We'll use it for algebra and expressions, but not for solving equations. On the solving equations, there's all your equals down the middle. They don't have to be beautifully lined up, but they go down the middle. And by the way, if you keep working down the page, when I compare a whole lot of students and some kept going across the page and they wrote all sorts of extra stuff, they'll usually go wrong, or they write something that's actually mathematically incorrect. So keeping down the page, one of the things is it's easier for your eyes to go from there to there, there to there, there to there, there to there. There's something about what we call tracking with your eyes, that this is the easiest and quickest ways to go down the page. That usually reduces people's errors. So I want to get rid of the 2x from the right hand side. So if I take 2x from the right, I take 2x from the left to balance it up. And now it's really easy. We've got 3x take 30 equals, they're gone. Don't have to cross them off, don't have to show anything. You can just write that down. Now we want the x by itself, so we're going to get rid of the 3, get rid of the minus 30. You can go divide 3, divide 3, divide 3. It just adds an extra little step in the working. On this one I can go plus 30, the opposite of minus 30, plus 30. By the way, 30 take 30 is 0, so again that's gone. I'm left with 3x equals 40, and you can see you can start getting some pretty revolting answers, but in real life you do. So what's in between the 3 and the x? There's the times, so the opposite of times 3 is divide 3, and if you haven't seen me talk about before, the quickest way to write divide 3 is that way, just means divide. And 3 into 3 is 1, so that's a 1x. 3 into 40 is actually the answer of 40 on 3. Of course you can go 3 into 40, 3 into 4 goes once and 1 left over. 3 into 10 is 3, and you've got the old remainder of 1. So there's your remainder of 1. We started with thirds, we end up with thirds. So of course you could write 13 to the third if you wanted to. Could talk about decimals for a moment. If you wrote 13.3 repeater, no one's going to take the mark off you. If you wrote 13.3, most of the time you'll lose the mark because you've lost a whole lot of accuracy. You're just going to chop off the others. If the question said, write your answer correct to 1 decimal place, that's okay. If the question said, write it to 2 decimal places, then you go 13.33.